So I will get started. So this is adding and subtracting radicals, basically square roots, cubed roots, all that kind of stuff. And so let's start with square roots, review what that means, because you have to have some understanding of what you've got when you're working with it. So a square root is defined in terms of the exponent. So a number is a square root of another if you can square it and get the second number. So when you do the square root, it's like you're going backwards. You're kind of undoing squaring. And the symbol that we use for a square root is called the radical sign. So we refer to these in general as radicals. And square roots in particular usually have two answers, a positive and a negative, but we won't have to worry about that for the adding and subtracting portion. So you can have more than just square roots because you can reverse other exponents, and so we just refer to these as nth roots. There's specific ones like cubed roots that have a name, but everything else doesn't really have a fancy name. But an nth root is just, it's undoing a specific exponent of n. And it has a very similar symbol, but it has the letter n. And the one thing I want to be careful about is that n is above the little symbol here. So this is really important for today. It is, oops, I was trying to get my laser pointer on. There we go. Okay. So there's like a little hook there. It's right above there. I usually try to write it in between where the V is right here, because we're going to be putting numbers in front with exponents, and so you don't want to get confused. So just make sure that whatever number you put here, try to put it in between the V. And in ALEKS, there's like a special symbol for this. So you don't create it by using exponents. There's a different symbol that you can click if you have to enter these things in. But that n is called the index. What is inside the square root? And when we refer to inside or inside the radical, inside means it's directly under that line above. So if you have something and it doesn't have a line over it, it's not inside. So if you want it to be part of the square root or the radical, it has to be under the line. So you have to pay attention to that in ALEKS as well. Because a lot of people will say, oh, my answer is right, but they actually wrote it outside when it's supposed to be inside, or they wrote it inside when it's supposed to be outside. So you have to pay attention to where that line goes. But anything under the line or inside the radical is called the radicand, and then this whole thing is just called a radical. And then, as I mentioned, we've got cubed roots, and that has a 3. Square root, we don't write the number, but you can also write it with the 2 in the index. That just means the same thing. We have 4th roots, 5th roots, and so many other numbers, but we don't work with those as often, but we will have 4th roots today just to kind of get you familiar with all these. So this is the important part, because when we are adding or subtracting radicals, you need to have like terms. And so you have to know, what does it mean for radicals to be like or to be similar? So if there's a variable outside the radical that's going to be in front, they have to basically be like terms themselves. So an example is if I saw like x and then the square root of 2 and then 3x and the square root of 2, any variable that's in front has to be the same. It has to be like terms. So those have to be identical. So they'll have the same letter, same variable, or same exponent. The numbers on the inside have to be identical for them to be like terms. So in addition to that matching, whatever is inside has to match. If there's variables on the inside, those also have to match. So you could have something like the square root of , and the square root of 6x. Those are not like terms because the number is different, but the variable is the same. But if you had the square root of 3x and like 2 and then the square root of 3x, those are like because you've got the same number on the inside and the same variable on the inside. And they have to be the same type of root. So you can't mix a square root and a cubed root. So they have to match. So there's several things that have to match. What's in front, what's on the inside, and then the radical. So they have to basically the same index, that's the type of root, and then the radicand has to match, and then you have to be careful about the outside part. So if those things all hold, they're considered like terms. And we'll have an example where you identify whether things are like or not to kind of practice this. So if you have radicals that are like terms, then you can add and subtract them, just like you would combine other like terms. When you do so, whatever is inside the radical, the radicand, the part underneath that line, does not change. That does not change. You're only combining what's in front of the square root or the radical symbol. So the index doesn't change either. You can't add 2 square roots and get a 4th root. So it stays as a square root. Only the part in front gets combined. And then if they are not like terms, you might have to simplify them in order to get them to be like terms. So we'll do some of that. I'll show some of that as well. But we're going to start with examples just to determine are these like terms or not, and then why or why not. So I'm going to just start with the top left. We've got the square root of 2 and then the cubed root of 2. So these are unlike. These are not like terms. Oops, I accidentally grabbed the highlighter instead of the pen. So these are not like terms. And this is because the index is different. One is a square root, one is a cubed root. So the index doesn't match. And so that's a square root versus a cubed root there. So that has to match in order for them to be like terms. So if we look at in the middle, the top middle one, we've got the square root of 2 and then 3 times the square root of 2. So these are like terms because the index matches, they're both square roots. And inside the square root, it matches as well, the radicand. So they're both square root of 2. Now, it doesn't matter that there's a number 3 in front because the numbers in front don't have to match. It just has to be if there's variables in front, they have to match. But numbers in front don't have to match. Now, on the top right, we have the square root of 2 and square root of 5. And these are not like terms. So they have the same index. They're both square roots, but the radicand, the part inside the square root, does not match. And it has to match. So the radicand does not match because we have 2 versus a 5. Those are not the same thing inside the square root. Now, bottom left, I'm throwing in some variables here because you're going to see these with numbers and with variables. So bottom left, we have 7 times the cubed root of x. Now, like I said, you want to be very careful. This 3 is not an exponent on the 7 because it's above the little hook thingy there. So if it was on the 7, it would actually be a little bit higher up here. So you want to be very careful. Don't get confused here. So that is not part of the 7. that is attached to here. It's a cubed root. So we've got 7 times the cubed root of x and the cubed root of x. So these are like terms because they have the same index. They're both cubed roots, and they have the same radicand, which is x inside the root. So if you're kind of confused with the symbols here, what's underneath here, this is the radicand, and then this n, that's the index. So, you know, you might need to kind of write that down to remind yourself what we're looking at. And notice how I wrote my n right above the v part. So that's how I make it so I don't get confused when I handwrite these things. So the middle one here, we've got the cubed root of x and the 4th root of x. So the radicand matches because they're both x inside there, but the index does not match. So these are not like terms. So the index does not match. And then bottom right, we've got 2 times the 4th root of x and x times the 4th root of 2. So these are not like terms. Even though they both have a 2 and x, they're in different places. So in front, we have a 2 versus an x. Those don't match. This doesn't match in 2 places. So we have a 2 in front versus x in front. And in order for them to be like terms, they don't both have to be x. If you have a variable, then they both need to have that variable. And the radicand, what's inside, doesn't match because one is x and one is 2. I wish we had a name for whatever's in front of the radical. Like, I guess the coefficient is technically what it is. But usually we think of coefficients with numbers, and here we have a variable in front, so it's not really a coefficient. Are there any questions on any of these 6 examples? Okay, so now let's just practice combining these. So we're going to add or subtract the radical expressions. So these are called radical expressions because it has a radical, has that square root symbol, and expressions means there's no equal sign. So, you know, if you're trying to figure out what you're looking at, you want to know what the vocabulary means. So the radical, and then it doesn't have an equal. Important to know because if there's no equal sign, we're not solving. All we can do is combine like terms. And then we're assuming that all variables are positive, and that's just so you don't have to worry about taking square roots and negatives and all that kind of stuff. So that's just kind of a side note to make our lives easier. So top left here, we've got 5 square root of a plus 3 square root of a. So these are like terms because they're both square roots and they both have a on the inside. So I can combine these. So I'm going to show the long way to do this. Basically, what you end up doing is you're kind of factoring out the a, or the square root of a part. We have talked about factoring. You can actually factor out square roots because that's what's in common. And so you get the square root of a times 8, because you can add the 5 plus 3. But we normally put the number in front, not in the back. And so we can use the commutative property, which allows you to flip-flop them, and we can just write this as 8 times the square root of a. And you just put the number in front. So this is the long way to do it using our math rules, but basically all you need to do is add the numbers in front, and then the square root of a just kind of hangs out. So you're not combining square roots, you're not adding what's inside the square roots, it just kind of hangs out there. So if we look at the example on the right, we've got 6, and then this is times the cubed root of 7. So that's not 6 to the third power, that's part of the radical, minus 2 times the cubed root of 7, and then plus the cubed root of 7. So if there's no number in front, you can treat that as a 1. So this is 6 times the cubed root of 7 minus 2 times the cubed root of 7, and then you can write a 1 here, plus 1 times the cubed root of 7. And so I'm trying to write my index as far away from the number as possible so it doesn't get confusing. And when we combine these, you basically just add all the numbers in front because they're all like terms. They have the same radical, the same index, same radicand. So you just do 6 minus 2, which is 4, and then 4 plus 1 is 5. So this will give you 5 times the cubed root of 7. Are there any questions so far in these two? Okay, so if no questions, I want you guys to try this bottom left one. I won't make you do the one on the right with the variables, but the bottom left one here. 13 times the square root of 11 minus the square root of 11. What would we, if we are to, that's a subtraction there, we're subtracting those. What are you going to get? $12 times the square root of 11. That is correct. So these are like terms. We've got 13 times the square root of 11, and then it's minus a 1 times the square root of 11, basically. And 13 minus 1 is 12. So we get 12 times the square root of 11. So you can think of this radical as basically acting like a variable. Instead of 13x minus x, which would give you 12x, we're just replacing x with a square root kind of thing. But it has the same rules as variables. You can combine them the same way. Now the bottom right, I didn't want to have you guys do this one because this one we do have a part that's not a like term. So we've got this 8 square root of x plus 2 times the square root of y minus 6 times the square root of x. So the 2 square root of y is not a like term to the other parts because it's got a different letter. So we can only combine the 8 times the square root of x with the minus 6 square root of x. And then we're just going to have this 2 square root of y left over. So the only thing we can combine are the like terms where they're both the square root of x. So you're going to have 8 minus 6, which is 2. So we get 2 times the square root of x plus 2 times the square root of y. But these are not like terms because one has a radicand of x, the other one has a radicand of y. So you can't combine those. And if you can't combine them, you leave them separate. It's like if we were doing 8x plus 2y minus 6x. Your final answer is going to have both x and y in it because those are not like terms. So sometimes you can't combine these all the way and you're stuck with multiple terms, but you do try to combine as much as possible. Are there any questions? No questions yet. You'll probably get some as we start ramping up in the difficulty, I'm sure. Okay, so these specifically cannot be simplified. And so this is the reason why is because they're not like terms, but we want to know what is specifically wrong with these. So top left, we have x times the fourth root of y minus y times the fourth root of x. So there are two reasons why we can't simplify this one. The first is because in front of the radicals, they're different variables. So in front of basically that fourth root, we have different variables. And they need to match in order for them to be able to be simplified. And in addition to that, inside the radical, we have different variables. So that's the radicand. But if you can just kind of put it in everyday words like this. So inside we have different variables. So they're not like terms because of these two things. They're not matching. Even though the index is the same, it is the fourth root, the rest of it doesn't match. On the right, we've got the cubed root of AB plus A times the cubed root of B. So these again have the same index. They're both cubed roots, but in front we have one with an A, one without, so those don't match. So in front of the cubed root, we have no A and I don't know how to put this. Maybe we should, okay. In front of the cubed root, they don't both have A. So in order for them to be like terms, it either both not have that variable or they both would have to have that variable. They'd have to match. But we also have inside the cubed root, they don't match. Because one is AB and the other one is just B. Bottom right or bottom left here, we've got the square root of 2t plus the cubed root of 2t. So these both have 2t inside, but the problem in this case is that the indexes don't match. And the index doesn't match because one's a square root, the other one's a cubed root. And this one on the right, actually, I'm going to make this a little different. I'm going to change this and just make it a square root here of 5c plus the square root 5c. Because this is something that I've seen a lot of people mess up. So if you look at these, notice where the line ends. These are not like terms because in the first one, only the 5 is in the radical. The second one, both the 5 and the c are in the radical. Yes, This is very tricky. A lot of people miss this. And I would say about 99% of the time that you think you have the right answer, but Alex is marking it wrong, is because of this difference. So the radicands don't match. So we have 5 versus 5c, because that c, if you have the square root of 5 and then c, that c not in the radical. So you really have to pay attention to where the line is, because that makes a difference. So this is one of those things where people get frustrated, because this is one of those things where you have to have the right details. Like if you have the littlest thing wrong, it will be marked wrong, and it's because technically it is wrong, because what you wrote maybe was not what you meant, because you didn't have the line in the right place, that sort of thing. If there are any questions on these 4? Okay, so here are some more complicated looking ones, and we're going to just use a calculator to do the fractions. Just make it easier here. Directions: perform the indicated operation. So that, again, that just means, you know, add, subtract, whatever you need to do. So top left, we've got 3/4 a times the 4th root of b plus 1/6 a times the 4th root of b. So these are like terms because you've got the same variable, you've got the same radical, and the same thing inside. So those whole portions match. The only thing that's different is the number, and that means they're basically like terms. So all we need to do is do 3/4 plus 1/6. So I'm going to actually write that out right here, so that way in your notes you know what's going on. Because otherwise, if you just wrote down the answer and did that on your calculator, you might be like, how do we get this number? So I'm going to just use my calculator to add these fractions together. Just makes our lives easier. And when you add 3/4 plus 1/6, you get 11/12. So our answer is 11/12 times a times the 4th root of b. And just notice I have a gap between my a and then my 4th root, just so it doesn't look like that 4 is on the a, because it's not attached to the a. I just try to make a gap there so it doesn't look confusing. And I recommend when you're writing these things by hand that you do try to be very careful so that you don't make your notes look, you don't accidentally misread your handwriting or something because of where you've put your numbers. So you just want to be very careful about that. Top right. So we've got square roots, that matches. They both have PQ under there. So you just literally do 7.5 minus 6.3. So even though it's like a decimal, it still works exactly the same. And when you subtract those on your calculator, you get 1.2. And then we have the square root of PQ. And notice that I made sure that my square root line is long enough so that both the P and the Q are inside there, because that's how they should be. So when you're writing these by hand, make sure that your line goes as far as you need it to. Because if you don't have your line as part of your symbol go far enough, like if you stopped your line here, then your Q is no longer inside the radical and it would be wrong. You'd have to make sure this line is going all the way across everything that's supposed to be underneath there. So don't get messy when you're handwriting because it will change the answer. Bottom left, again, these are like terms because they both have a z in front. They are both cubed roots, and they both have 6 as the radicand. So all we need to do is add the numbers. So again, you're just doing 5/6 plus 7/9. And I'm going to just, again, write that out so that you have that and you're not just like, where did this number come from? It's not obvious. So I'm going to just use my calculator again, 5/6 plus 7/9. And then we want to make, this is going to be an improper fraction. It comes out to 29/18. Just gross, but that's why we have calculators. And then that's a z. And I always make sure my z looks different from my 2. And then it is a cubed root of 6. Then the last one on the right, we've got 0.81 x times the square root of y minus 0.11 x times the square root of y. So they both have x in front. They both are square roots. They both have y inside the square root. So these are like terms. So you just do 0.81 minus 0.11. And so just to be clear, what we're doing is we are basically, it's like you're taking ignore the square root part. You know, you're taking 0.81x minus 0.11x. We know how to do that. We've combined variables with x before. So when you do that, you get 0.7x, and then we've got our square root of y. So that's why the front of these also has to match, is because that's what you're combining. You're combining the front, whatever is in front of that square root. So they both have to have an x, or they're not going to be, you can't combine them here. Are there any questions? Okay, so now we're going to throw you into the things where they don't look like they match. So the directions here say simplify if possible. What this means is try to combine them if you can, you know, do the addition, all of that. So the word simplify is not any different from what we've been doing. It's just shorter to write. So if you look at on the left, we have the square root of 32 and the square root of 50. These do not match. So as we see them right now, they are not like terms. However, these are not in their simplified form. So we always have to simplify radicals, and that's because that's what we use when we work with them. And simplifying radicals means try to make what's inside the square root or cubed root or whatever radical it is, you want to try to make it as small as possible. So we need to simplify the 32 and simplify the 50. And so I do this by making factor trees. So I take 32, and I'm also going to do this with 50. And I just split it up as two numbers that multiply to these things. So like 32 I know is 8 times 4. And 8 is 2 times 4. And 4 is 2 times 2. So I just kind of make a tree. And then every time I get down to something that cannot be split up, I circle it. 50, well, I know that's 25 times 2, and 25 is 5 times 5. So I make a factor tree when I'm simplifying these things. And what this allows me to do is to rewrite 32 as its product of prime form. So I've got 5, and then instead of 32, in order to create the number 32, I have 1, 2, 3, 4, 5 2s. So that's going to be 2 to the 5th. So I'm replacing 32 with 2 to the 5th because those are the same thing. And then 50 is, I've got 2 times 5 squared. I'm kind of squeezing it in there because there's 2 5s there. So I've just kind of rewritten these in their prime form, or their product of prime form. And then to simplify square roots, you want to have exponents that can be divisible by 2 because it's a square root. That would be a 2. So I do have a video on how to simplify these kind of things. So we want to kind of rewrite these so that your exponent is, for square root, want to have even powers. So I'm just going to kind of move this down here. So I've got 5, and then I can rewrite my 2 to the 5th as 2 to the 4th times 2, because that will still give me 2 to the 5th. I just kind of pulled one away so that I had something with an even exponent. And then I have my 2, and then I'm going to put my 5 squared in front instead of the 2, just so that I can put my even exponent part in front, inside the radical. But these are all still inside the radicals. And then anything with an even power, because it's a square root, can be removed from the radical by dividing the exponent by 2. So this gives me 5, and these get multiplied together. So that's going to become 2 squared outside. And then I have plus 2, and then 5 squared, when you divide that by 2, you just have an exponent of 1. So what I took the square root of ended up in front. And now, never mind what the numbers are in front. What's important is that now we have like terms. So by simplifying these, they both ended up having a square root of 2. So now these are like terms. So now I can combine them. But in order to combine them, I need to do the math. So I have to do all the multiplication in front. So I've got 5 times 2 squared. So 2 squared is 4, and 5 times 4 is 20. So this is going to be 20 times the square root of 2, plus, and then 2 times 5 is 10. So that's 10 times the square root of 2. And now you can see these are like terms. So I do 20 plus 10, and my answer is going to be 30 times the square root of 2. And there's no shortcut to kind of getting this answer from the very beginning. If you look at it, we had 5 times the square root of 32 plus 2 times the square root of 50. There's not really any way to kind of find a pattern to get to this shortcut. You have to go through this work. But this is, this is what we have to do in order to actually simplify these things. So before I do the second example, are there any questions? Why did I divide 32 by 4? I could have done it by 2. I could have done 32 is 16 times 2. I didn't do it that way because that's not the first pairing that came to my head. I always do the first pair that comes to my head, and you know, I don't really know my 16 times tables, but I sure know my 4s and my 8s. So I know that 8 times 4 is 32. But that's the thing with factor trees is you can make the tree different ways. You'll still get to the same solution. It just depends on which two numbers you start with. No, there is no extra time on this week's quiz, but let me actually open up the quiz and see how many questions like this you have, because I know just to make you feel better, because I could tell you that there are not going to be a lot of these on the quiz, but I will open it up just to be safe. Give me a moment, and also gives you time to think of more questions in case you have some. There is only one question on the quiz where you will have to add or subtract these things. There is one question where you do have to simplify, and there's one question where you're doing a multiplication problem. So don't worry, there's not a ton of the adding subtracting on there. Okay, so let's move on to the one on the right. We've got 7 times the square root of 40 minus the square root of 8 plus 4 times the square root of 50. Now, if you are worried about running out of time on the quiz, what you might want to do is maybe start writing a cheat sheet or running tally of what, you know, certain square roots are. Like on the left, we determined that the square root of 50 was basically equal to the square root of 5 squared times 2, which gave us 5 times the square root of 2. So instead of going through my work again to find the square root of 50 here to simplify it, I'm going to just reuse the work that I already did. So as you go through the homework, you know, or even if before you take the quiz, if you want to just go through your notes, in each radical that you simplified, maybe write it down somewhere. Maybe make sure you put them in numerical order from the here, and then write down the answer, and that will save you some time because you'll have them written down there. So just, you know, if you're worried about time, that would be what you can do. And then, so question, what did we do to get 5 on the outside? That was coming from this 5 squared. So once the square root, to get it on the outside, you divide the exponent by 2. So since the exponent was 2, 2 divided by 2 is 1, so we just have a single 5 on the outside. And then that square root of 2 stays there because we can't, that exponent is 1. If you divide it by 2, you get a decimal, and that's not going to make sense. So we've got 7 times the square root of 40. So I need to split 40 up. And so first thing I think of is 4 times 10. 4 times is 2 times 2. And 10 is 2 times 5. We've got the square root of 8, and we know that's 4 times 2. whoops, 4, it can be split up as 2 times 2. And then we've already got the square root of 50, which we did already. So I'm going to rewrite this. I've got 7 times the square root, and now with 40, I've got 1, 2, 3 2's, so that's going to be 2 cubed times a 5. Then I have a minus, and you can put a 1 in front of there, and then the square root of 8, we've got 3 2's. And then we've got plus 4, and then we already determined that the square root of 50 was 5 times the square root of 2. So I'm just, because we already did that, I'm just going to replace that and have that there already. So because these are square roots, we want to have our exponents in even powers inside. So the 2 cubed times 5, I'm going to split that up as 2 squared. And then I pulled out a 2, so I still have 3 2's there, times 5. And then watch as I make sure that I have my line covering everything. And then I want to do the same thing with this 2 cubed, 2 squared times 2. So there's still 3 of them there. And then I've got 4 times 5, so that's 20. And then my square root of 2. Now, everything with an even exponent, I can take the square root of, which means that I'm dividing it by 2, the exponent by 2. So that's going to give me 2, and then 2 squared is going to come out as 2 when it's outside the square root. Then I have minus 1 times 2 squared, again, becomes a 2 when it comes outside. And then I've got square root of 2. And then I've got 20 times the square root of 2. So now I'm going to multiply the numbers in front. So 7 times 2 is 14. So I have 14. And then 2 times 5 is 10. So I'm going to kind of recombine that because it can't be simplified further. Then 1 times 2 is 2. So it's going to be 2 times the square root of 2. And then plus 20 times the square root of 2. So now the square root of 10 is not a like term with the square root of 2 pieces because it's got a different number underneath there when we simplified. So we can't combine the 14 square root of 10 with anything. We can only combine the things with the square root of 2. So my final answer is going to have 14 times the square root of 10. And then I've got a minus 2 plus 20, which is going to give me 18 times the square root of 2. So we can't fully simplify this to one number or one thing with a radical because not all of the radicals were like terms. But we wouldn't know that until we simplified all of them first and then combined what we could. So what, do you guys have questions? I can highlight what we pulled out because we took it out of the square root there. The 2 squareds become 2's when you take the square root. There are questions. Maybe there's not. Yes. So a question is, do we stop the factorization stuff when prime numbers are involved? Yes, because you can't factor a prime number. You stop once you hit a prime number because that's as far as it can go. So you just keep going until all you have left are prime numbers. There are other questions. And why are we pulling only 1, 2 from the 2 cubed? So we have to get the exponent on whatever is inside the square root to be even in order to take the square root. So if you've got 2 cubed, you only need to pull 1 away in order to get something that has an even exponent. Yeah, and you want an even because it's a square root. Because the exponent of a square root is, whenever you take a root, you're dividing the exponent by the index. So a square root has an index of 2, so you have to be able to divide the exponent by 2, which means even. If it was a cubed root, you have to divide the exponent by 3 because it's a cube. So whatever the index is, you need your exponent to be divisible by that. There is a video in the classroom. I'll just, it will look like this, basically simplifying expressions of the form, and it goes over those rules. So if you need a refresher on that, this should be listed in the video section for week 3 for this particular, for the homework on radicals. And so this is the title and what it's going to have, and it goes through those rules. So I want to go over one that has variables. We only have 6 minutes, so I'm going to do the one on the left. I have way more examples than we have time for, so I'm going to do the one on the left because that will be, you know what, actually I think the one on the right, it will be faster. So we'll do the one on the right. So we've got 6 times the cubed root of y to the 10th minus 3y squared cubed root y to the 4th. So right now, the only thing that matches is the index. These are both cubed roots, but that's the only thing that matches there. So we have to simplify these in order to try to combine these. And so these are cubed roots, so we want our exponents to be divisible by 3 because that's what the index is. So if I take my 6, I've got my cubed root, and instead of y to the 10th, I can write it as y to the 9th times y, because I can divide 9 by 3. So in this case, instead of having even, we want to have it divisible by 3 because that's what the index is. Then I've got minus 3y squared, and notice the difference between the y squared and the cubed root symbol. That, you know, they're different sizes there. You want to pay attention to that. And then I can't divide an exponent of 4 by 3, but I can make it y cubed times y. And then I do have something that I can divide by 3. So we're going to take the cubed root now. So all of these things that have exponents of 3 are going to have their exponents divided by 3 because it's a cubed root. And that will pull it outside of the radical. So I'm going to have 6, and then y to the 9th, 9 divided by 3 is 3, so that becomes y cubed when I pull it out, which then gives me a y cubed. So this y cubed came from taking the cubed root of y to the 9th. Then I have minus 3y squared. And then when you take the y cubed, 3 divided by 3 is 1, so that pulls out as just a single y. And then I have my cubed root of y. So that y came from taking the cubed root of y cubed. So maybe it's, if I highlight just partial of the cubed root, that might be able, you might be able to see that a little better. So 6y cubed times the cubed root of y, there's nothing I can really do there other than make sure that when I write it, I don't get my exponent in the cubed part like all that confused. Then I have minus 3y squared times y, which becomes a y cubed when you multiply those together. And then times y cubed y. And now we have like terms because they both have a y cubed in front. So that matches. And they both have the cubed root of y. So because all of that matches, we can now combine these. So we just got the numbers 6 minus 3. So this is going to be 3. Then we have y cubed times the cubed root of y. So we basically did the same thing that we did in the other example with the numbers, but I think it's a lot easier to see what's happening when you don't have numbers involved, when you just have variables. But we have to simplify inside the radical first by pulling out as much as we can. And then when we get things that are like terms, you combine them to get your final answer. Are there any questions? So cubed root, no. So the question was cubed root, so we want odds. It's not that you want odds. It has to be divisible by 3 because the index is 3. So I could have also split this up and had an exponent of 6. I can divide 6 by 3, so that would work as well. They have to be, the exponent has to be divisible by the index. So it's not even or odd. It's whether can I divide it by the index. And if for a square root, it was even because every even number is divided by 2. But for cubed root, there are some even numbers that are divided by 3. There are some odd numbers that are divided by 3. So the key is it has to be divisible by the index, which is that number right above the radical symbol. Other questions? Okay, so I had more than enough examples here. I have several, so what I'm going to do is put the answers to them at the bottom, so that way tomorrow when I email this out, if you want to do extra practice, the answer will be at the bottom so you can double check yourself and see if you can get the correct answer, because I have a lot of extra ones. So I do recommend waiting until maybe tomorrow to take your quiz, just to give yourself enough practice on this kind of stuff. Do some more practice tomorrow because, you know, this stuff is a little harder. So, you know, don't rush to take the quiz. Other things on the quiz, since we were talking about it, you're going to have complex numbers on there. There's going to be 2 questions like that. There's going to be solving quadratics. 2 of those. There is going to be rational expressions, because we did talk about rational expressions. So that's the fraction ones. You're going to have 3 of those. So, you know, if there's something that out of those topics that you know you need more practice on, definitely take the time to practice that. And, you know, when you're taking the quiz, if you know that you're on a problem that's going to take you a long time, maybe just skip it and come back to it and go to another one that might go faster. So what I suggest some people do is just set a 5-minute timer on their phone, and when it goes off, move to the next question, and then whatever extra time you have at the end, you can go back. So that would be my recommendation. So, okay, well, I will let you guys go. Next week, because there is no holiday next week, it will be on Sunday night. You know, moved this one because people wanted to go trick-or-treating with their kids, which I totally understand. So that actually allowed me to give candy to kids myself. So that actually worked out. So I will see you guys next week. Let me know if you guys have any questions, and have a great rest of your night. Bye.